do. Okay. Looks like it's gonna be a medium. Minimum deletion is to make string balance. You're given a string S consisting only of characters A and B. You can delete any number of characters in S such to make S balanced. S is balanced if there are no pair of indices I, j such that I is less than j, and S of I equals the letter B and S of j is equal to letter A. Balanced. I think I understand, so that means that for every B, there's a following A in it. For every B, there's a following A, so these two A's need to get away. And then there's only two A's remaining, so I think you have to delete two more B's, like this B and this B. So you have to delete 4 things, and you're left with BA, BA. And that's balanced. BBAA, and a bunch of A's and 2 B's. These B's will never be balanced. And then these A's will balance with these B's. So you have, so you're left with again 2 B's and 2 A's. Okay, this is close to easy. I can see why it's not easy, or why they don't classify this as easy. But this is pretty close to easy. So I think you just need to like do the logic of how many B's there are at a certain point, and then like, yeah, how many B's there are at this certain point. So I think, how would I classify this? This is probably just a greedy approach. This is a greedy approach. No, I guess you can't do greedy approach, right? You can't just assume. All right. Well, let's say I have a keep number, and every time I see a B, I increment. So I'll have an A count and a B count. Guess they're all equal to 0 at the start. A count, B count. Every time I see a B, I increment the B count. That's fine. Every time I see an A, actually, yeah. Every time I see an A when the B count is above 0, which means that there was a prior B, I decrement the B count and increment keep. So I'm keeping that A, and the A is balanced with that prior B. So this is kind of a greedy approach because you can immediately determine based on when you see an A what to do with the answer. So anyways, for every index, I don't even think I even need to know the indices. For every letter in the string, if the letter is a B, obviously you would increment the B count. Else, if it's an A, then you do the logic. So if it's an A, then this is going to be balanced with the prior B. So else, if the B count is greater than 0, then this means that there's a balancing B before this A. Keep is going to increment, and B count is going to decrement. And that's pretty much it. Yeah, so this is kind of just like a logic. I'm pretty sure this works. Actually, the keep is half the size of the string. Or I guess you're actually calculating return the minimum number of deletions. Wait. Am I thinking incorrectly? Why is the minimum number of deletions here 2? Any number of characters in S to make S balanced. You can delete characters 0, index position 2 and 6. You can do any number of characters in S to make S balanced. Turn in minimum number of deletions. The characters 0 index positions 2 and 6. 2 and 6. Oh, it's A before B, not B before A. Whoops. Okay, yeah, I think the logic still applies. Wait, really? A, yeah, so you have 3 A's and then 3 B's. Oh, you can delete any numbers if there are no indices such that I, man, I'm speed ran the reading and didn't actually catch the meaning correctly. S is balanced if there are no pair of indices such that I is less than J, and S of I is equal to B, and S of J equals A. Oh, you want to delete it so that you have a string where it's only A's followed by B's, any number of A's followed by any number of B's, and you want to see the minimum number of that. Oh, wow, I really misread that. So the best thing here is keeping 3 A's and then deleting this A, deleting this B. Here's deleting these 2 B's. Okay. Yeah, so this is going to be much harder. So you want A's before B's. So I think example 1 is one I really want to think about. Example 2 is kind of whatever. You know that you have to delete all the B's that start before any A's. There are no pair of indices, or I guess that's not true, right? You could actually have, let's say, 1,000 B's and then an A. You probably want to delete the single A at the end, and then just have a string of all B's. Let me double check that. Assume that returning 0 should be correct in the case of like a bunch of B's. I think here it should be 1. Just delete the single A is the best way to handle this. Okay, yeah. So at any given index, if it is the case that if it's a B and you want to keep that B, the cost would mean that you delete any prior deletions and any remaining A's. must delete, like the cost being the number of deletions, must delete all following A's. And then to keep an A, then that means you must have deleted all previous B's, right? To keep a B, you must delete all following A's. Uh, do 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 do. Can I do this with a sliding window somehow? I think maybe. I think the simplest thing would be just have kind of have an array that tracks the number of following A's from any given index. So following A, I'll just make that an array. And I'll go backwards through the string to keep that. For I in range n minus 1, -1, -1. The number of following A's. The number of following A's is inclusive of this index or not? Probably inclusive. If S at this index equals A count increments following A at this index is equal to the A count. Right, just double check this is working as intended. Okay, so there's 0 following A's at the end of this B. There's 1 here, 1 here, 1 here, 2, 2, 3 inclusive here, 4 inclusive first. Okay. Looks like that's what I intended. So yeah, so I think it's just the sum for every index. I'm just trying to find the minimum of these, the minimum sum, where the sum is these two values, the number of previous B's and number of following A's. And I think I need to do 2 passes in order to do that. I don't think I can do 1 pass. Can I do 1 pass? I kind of need to know. I think I actually can do 1 pass. Because I just need to count the number of A's and then subtract that as I do the first pass. Okay, never mind. Okay, so I think this should be total A. Total A is going to be the count of how do I do a count in strings? Python count letter in string. What's the function here? No, count the frequency. Uh, frequency. Oh, it's dot count. That's right. S dot count A. Okay, so for every, say, index in range n. Actually, do I even need to know the index? I guess I don't. For every letter in the string, for each loops are slightly faster than indices loops. For each letter in string. I think I need to know. So basically, I'm considering whether or not I want to be at this point to be the point where I have deleted all prior B's and I'm keeping this letter, kind of. Like all prior B's I delete, all following A's I delete. Is that how I want to think about this? If it's an A, so let's say if the letter is an A, no, this is not right. If the letter is an A and I'm keeping in this index, then I still, if there's like a following B and then A, I could delete the B to make that right. I could delete the A's to make that right. Oh boy, this is much more difficult than I was thinking. Oh boy. Then you consider at each index. So there, at each index, if I consider that the index where it kind of separates all prior A's I keep and all following B's I keep, then the cost of deleting all prior B's and deleting all following A's is the cost of that index. Is the cost of basically making that index be the kind of pivot index between the balancing point. I guess that still should work, right? Prior all following A's to that point, all prior B's to that point. Okay, maybe I'm just confusing myself right now. Total A is equal to the string counting A, and then the B count needs to be kept while I do the loop for every letter in the string. I think I first evaluate using that letter. Do I need to evaluate before or after? Updating the counts here. I think theoretically I should be updating afterwards, but that's kind of opposite of what I'm used to. Maybe this might just be a fence post issue where I need to do something after the for loop, regardless how I should structure it. Or maybe the answer should be initialized to total because I could delete all the A's. Yeah, maybe that's the fence post I want to think about. Yeah, answer equals total equals that. Because it could be that my initial attempt to balance it is just deleting all the A's and just having a string of all B's. Yeah, okay. So here again, I'll update and then I'll check if the answer is improved by the current. So update is update costs associated with trying to balance at this index letter. So if the letter is A, then the total is decremented. Why do I even need B count if I can just do total minus the length minus the total A as the B count? Yeah, no. I mean, one is decreasing, one is increasing. Total falling A's. Total falling A's. The total prior B's. If the, I'll say this is prior B, follow A. If the letter is an A, then the following A's is going to decrease. If the letter is a B, then the prior B's is going to increase. If the sum of the number of prior B's that you need to delete plus the sum of the following A's you need to delete is less than the answer. I think this might be off by 1 somehow. Or not. I think of the math here. The math here seems somewhat weird. Like, why do you need track of the? I'm not sure why you need to keep track of prior B if this is the logic. Like, isn't prior B? Can't that just be calculated from the total minus the follow A? Okay, I think I just need to actually do an example here. S equals AA, BA, BB, AB. So the follow A is the total number of A's, which is 1, 2, 3, 4. And the prior B's starts at 0. So at the first letter, it's an A, so the following A becomes 3. Okay, yeah, I guess if you just note 3 and you know that there are 1, 2, 3, 4, 5, 6, 7, 8 letters. Yeah, okay, yeah. This is not quite the calculation of like total minus follow A equals prior B, because they're not actually summing up the total. Okay. It's almost like a seesaw, but not quite a seesaw. All right. Okay. Sure. There's something faster than this. Something faster than this. I think I know how to make this slightly faster. I create an array, so instead of doing this thing to find the minimum, I just store the value of prior A or prior B plus follow A into this deletions array, and then find the minimum of that. Because it's faster to find minimums using just more space like this, I think. That's what I've seen. Oh my god, it doesn't work. Answer equals minimum of deletions. Oh my gosh. It needs to initialize to follow A. Whoops. Okay. I think this is faster. Wonder if I should use an if statement like this or if I use a case. Wow, it's not even faster. Considerably slower even. Um, oh, oh. Considerably slower even. That was so much slower. All right, theory rejected. How to make this? I need to know the length of n. I guess that I can remove that, right? Do. Same speed. I mean, I could try to handle something that is like a trivial case in terms of like a one string. Like if the string is length 1 or less, just keep it. Like you wouldn't need to delete anything in that case. That seems like it should not be significantly changing anything. Maybe it slows it down, I don't know. Can't think of anything else that's kind of obvious to improve it. Surprised that can improve from this, to be honest. Alright, well, it is what it is. Okay. After much confused thinking from me not understanding the setup problem, finally came to the realization that that a working approach is to consider each index as the kind of middle where the string divides A's to B's. At that middle point or position, I guess, would need to delete all prior B's and all following A's. So for example, if you had the starting string, what was it? No, well, let's just go random string here. So let's say you're considering like this being that point. So if keeping that middle pivot, then need to delete the two prior B's so that you have just all A's before that, and three following A's. So you delete like this A, this A, this A, because again that point needs to be where A and B kind of separates. Do that for every position. Find the or calculate that cost for every position and keep track of the lowest cost. That'll be your answer. Also be aware of fence post issues. Initialized. I initialized the starting answer value, kind of lowest number of deletions as the total number of A's, which is say that kind of initial cost is to find deletions to get all B's. But yeah, you can handle it differently as long as you're consistent with it, because you need to do something with like how you want to handle the starting index or the last index. Alright, time complexity is going to be O of n, where n is the number of letters in the string. This is needed in order to get the count of A's that I used using the count function, and also to iterate over every index. And then space complexity, this is going to be O of 1. No, sorry. Yeah, O of 1. Since no extra space is needed. I'm really not sure how people got considerably faster than this solution, but whatever. Seems like pretty